All right, guys. So it's a nice Saturday afternoon, or afternoon, after, and it's very nice weather. I'm not sure why we are even having a class for this weekend, and from Monday there will be, cold weather again coming back here. That was the free weather report. Now let's get back to what we were doing. AWS VPC features. We're going to explore some more. Like I'm gonna go to the VPC dashboard here with so many millions of things open here, and the VPC dashboard. So we have gone, we've created a lot of stuff here. Your VPC, we create VPC subnets, route tables, internet gateways. Then there are other features as well. Some of the labs I'm gonna, oh man, seriously, you can see that how far and long it is. So we're gonna go a bit. We're gonna go ahead. So there is that egress only internet gateway. So egress is outgoing traffic, and the info says here an egress only internet gateway is a horizontally scaled, redundant, and highly available VPC component allows outbound communication. So that's the main word here. Outbound communication over IPv6 from instances in your VPC to the internet, um, and to the internet, and prevents the internet from initiating an IPv6 connection with your instances. So basically, it's and I was going to say purely IPv6 connection based services it's going to support. So outbound traffic going from your VPC. So if we go to our Gaia and Gram. So if there is a VPC here, and there's a subnet here with the VPC, and then there is a subnet here. So whatever services are offered now, obviously services would be some application or maybe a virtual machine, EC2 instance that is. So that would be some data going out of that. So if that data is moving out of the a VPC, first of all, it's outbound traffic, or we can call it egress, and ingress, the other side of it. The other word is ingress. This is e and gress. The other one is ingress. Ingress is inbound, egress is outbound. But it also is talking about IPv6. If you are using in your application IPv6, then it provides you a gateway, which means gateway just means that the gateway just means that where the traffic enters from internet to your network, or from your network through gateway to internet, right? So that's what a gateway is. So if there are IPv6 based traffic, so if I go back here, there's an egress only internet gateways for use with IPv6 traffic only. To enable outbound only internet communication over IPv4, use a NAT gateway for that. So that's another thing, a NAT gateway. So I will be preparing a lab for NAT gateways soon, and send you a video for that. Some of the labs are there, but some of the labs I will be preparing. So here, yes, as we talk about egress, so create egress only internet gateway, which means that if you create a gateway, just like we created an internet gateway, first you create a gateway, then you connect it to a VPC, right? So you create but if you have IPv6 based traffic, then only it is useful. Till now, still a majority of the companies are using IPv4 based traffic, but IPv6 based traffic will still be coming soon. You have to enable it on your EC2 instances. Depends on which operating system you have, and then you configure IPv6 there in Windows or in Linux. Then this is useful. Otherwise, in near future, it might be coming, but for now, it's IPv4. So this means that NAT gateway is the one that is being used right nowadays and in near future as well until IPv6 comes over. So this is the rules that you can govern for IPv6 based traffic. Then there's carrier gateways here. Carrier gateway, well, carrier of what? Traffic. So a carrier gateway provides connectivity to the carrier network for resources in a wavelength VPC. Okay, so what is a wavelength VPC for which a carrier gateway provides connectivity? So wavelength zone opt-in required. Now, what is wavelength? Wavelength is that AWS wavelength enables developers to build applications that deliver ultra low latencies to what? To mobile devices and end users. So that would be the thing that if any of the applications on AWS are connecting to mobile devices with your developers are coming up with some applications that are connecting to mobile devices, then the wavelength, AWS wavelength really offers that connectivity. Wavelength deploys standard AWS compute and storage services to the edge of communication service providers, 5G network. So if you are connected to 5G networks, if you are connected to your communication service provider like telecom, here it's Rogers and Bell, right, and many others. So if you're connecting to suppose Bell telecom provider and they are offering 5G networks to your mobile users that are connecting to your services in AWS with the 5G networks. So then you need AWS wavelength to be configured. Otherwise, no need for that when you're working within AWS and creating your VPC and EC2 instances and subnets and route tables. Now, you can extend a virtual private cloud to one or more wavelength zones. And obviously, if you're connecting, so if I go back to the diagram here, that would be another subnet that would have connectivity to wavelength zone. So this means that the virtual machines or any data that is connecting to this subnet, and this subnet is connected to the wavelength zone, right? Wavelength zone, and that wavelength zone is connected to some CSP, which is communication provider. Actually, it's cloud service provider as well, but this is some telecom. So it's not a cloud service; it's a communication service provider, as AWS is referring to them. This telecom, and from telecom, it's connecting to your cell phones. So obviously, you will use that wavelength service. Now, the carrier gateway. Carrier gateway would be between this communication. That carrier gateway, as we know that what gateway exactly does, that's exactly what carrier gateway will do. It will just simply provide connectivity between the AWS side of networking to the telecom side of networking. And that's what you have to deploy and pay for if you are connecting your data through wavelength zones, through Care Gateway, the connectivity will be provided to telecom services. Telecom services will connect to the cell phones. So whatever application you're creating, your developers will be creating that application. they will then need the wavelength zone and carrier gateway services connect to telecom services. You have to pay for telecom services as well if they are providing 5G networks. Okay? So, 5G networks. So I think Bell and Rogers both are providing that, or at least I know Bell is providing that 5G network, which is obviously much more faster. And I think Chinese Huawei was coming into the market in North America first providing 5G networks, but security reasons then, and for rivalry reasons, Huawei network was rejected by all Western countries. So that's the 5G network. Then now others are also, you know, adopting Bell and Rogers. This is how it will then work. You can extend a virtual private VPC to one or more wavelength zones. You can then use AWS resources like Amazon Elastic Compute Cloud or EC2 instances to run the applications that require ultra low latency. So very fast communication or very low latency or being late delivered data would be very low and a connection to AWS services in the region. Especially if you have that kind of infrastructure, then you need the services. If we go for enable traffic to telco carriers using carrier gateways, a carrier gateway would be serves two purposes. It allows inbound traffic from a carrier network. In a specific, so carrier network is what? L Rogers, right? In a specific location, and it allows outbound traffic to sorry, the carrier network and the internet. Excuse me. So there's no inbound connection configuration from the internet to a wavelength zone through the carrier gateway. Carrier gateway supports IPv4 traffic. So overall, this is if you have that kind of infrastructure, you have developers, and you're creating some kind of applications, to the cell phones, to your employee cell phone or your customer cell phone, some specific application that was created here, and that it does something. Suppose it's Bitcoin or any other currency related application that needs to be served in cell phones. There are many apps that are only cell phone based and they have no presence on internet. They're just you can only download from cell phone and connect through cell phone telecom and internet obviously, but they don't have websites or anything. So if you have that kind of infrastructure, then you can use this service. So I'll just add that. Okay, so if we go ahead, there's DHCP option sets. This just simply tells you, or DHCP option sets is available. Let me just create another background here. When you want to give DHCP services in your VPC, in your subnet, then you use DHCP option sets. We haven't used that because we didn't need that. But suppose you want to give some kind of DHCP services across your subnets, then you can really do that. So let me just type VPC with rate. I'll just create a diagram for that so I can use it in future. And subnet. Subnet 1, subnet 2. All right. So I'll just take that as a screenshot and put it in my collection of diagrams. I can use it later. Okay. Wow, the weather today is amazing. Okay. Let me just put that in my collection of diagrams. So I don't have to create it again and again. So And the DHCP option set is obviously what DHCP does is DHCP is dynamic host configuration protocol, so DHCP. And that DHCP will provide automatic IP addressing. So DHCP option set is just whatever information you want to give to the client. So first of all, what does it do? Let me just create some virtual machines. Suppose there are 20, 50, 100 virtual machines here. And when the virtual machines start, suppose you don't give it static IP or the IP you manually give. Suppose you don't want to give that, then you can give here through DHCP an IP as well. The DHCP will automatically provide an IP. We've created so many EC2 instances in the labs, and you can see that IPs were distributed automatically. So the DHCP is there already with each subnet. You want to create your own DHCP option set, which means that what is the domain that all the clients need to know. Suppose you are, remember that we created a domain as well with the Active Directory. So you want to give the clients some information you don't want to give manually. So you put it to DHCP, and DHCP automatically, when it is providing IP addresses, will give some extra information that you have to give it to the clients. So then you create a DHCP option sets if your what you information you provide is customized, is something that by default is not present in subnets, in subnet based DHCP or DHCP connected to subnets, right? So if we go here, DHCP option subnets and create DHCP option set here. So here we can just give our DHCP option dash set. And then suppose you want to give clients the information through DHCP instead of you putting that information manually. Now maybe you created a domain or domain.local or your first name domain.local, and what are the DNS services that are available now within the subnet? You already have, in fact, the VPC level subnet DNS services are provided. So I'll show you on the VCP level. VC, the DNS services are already provided there. And where are they? Let me just quickly show you that as well. In fact, obviously I'll have to then duplicate this and create one sample VPC. Clean. Some VPCs already created availability to be. This is source. Okay. Well, there's a DHCP already created here, test one, and that is just a simple DHCP that does nothing much. So this VPC is ending with 2892C9, right? And I'll just name it Honor VPC or something like that. This is Honor-VPC. I would know that which one to delete. Okay, and what is saying that DNS services, if I go to edit VPC settings, any VPC, create, if you go to the edit VPC settings, so there's enable DNS resolution, enable DNS host names, and enable network address usage metrics. So pretty much it's going to resolve IPs to names automatically. And recording is going on. Thank you for coming. I just saw that message. Okay, so here enable DNS. So what I'm saying in the diagram that or in fact where we were in the interface, we were here, right? We were saying, hey, do you have any of your own DNS servers? Or if you leave it blank, then it will just simply use what is provided by VPC. So VPC has DNS services. I already showed you where it is, and that is here. DNS is already enabled. VPC when you create. Actually, if you create, suppose I create a new VPC here, right? And Amir dash VPC dash 2 and give some range slash 4, whichever range you want to give, and create a VPC. So when you create a VPC, new VPC, that is, so that's VPC 2 now. You go there and click actions and go to edit VPC settings. So these two, enable DNS host names and enable network address usage metrics, are not by default enabled. So you have to enable that yourself manually in order to then for the DHCP to take benefit of DNS services, right? So here I had already enabled that for some other thing I was doing, so that's why it was checked. Otherwise, normally they're not checked. So name resolution by default for EC2 instances or virtual machines is not enabled. You have to enable it yourself. DHCP option set. We were talking about that, so let's continue configuring that. So I don't have a separate DNS server. What is a separate DNS server? Even if I try to have, so I can install Windows in a EC2 instance, and then I can install here a DNS. So that will be my DNS server. Then I can give the IP of that machine. Hey, from that machine you can resolve name. You can do name resolution services, right? So you can do that, but I don't have a virtual machine or EC2 instances. Suppose I don't have, and I don't want to have, because I know VPC provides DNS services. So why should I just separately create my EC2 instance and install DNS service and then provide that? So I'll leave it blank. NTP servers, which is network time protocol. Now VPC does that too. It's by default it does that. It does not have that option to click. It provides time correction services. So NTP is network time protocol. So time correction services can be. And so we don't need to really provide that unless you have some kind of device here, and that device, suppose there's a device and that's NTP device, and that device actually synchronizes its time with some internet time device. So that also happens in networks, internet. So suppose we go here and NTP sites. So there are some sites that your devices can connect to, and this is Cloudflare offers one Google public NTP. If you put time.google.com, so your devices will correct its time or synchronize its time with certain devices or time services on the internet. So that can be provided as well. So you can give time.google.com here if you want to get synchronized with Google time, or you can leave it as is, and it's in North Virginia, this VPC, so it will just simply synchronize your time, the correct time. BIOS name servers, so this is supposed to be just Windows based name resolution that is deprecated now. This is also name resolution service. DNS is also name resolution service. This is legacy one. Suppose there are some old companies or big companies that are here for 2 decades and they have old Windows servers as well. Many companies did not migrate till now. So in that case, it's already deprecated, but it's for backward compatibility or legacy machines or older Windows servers if they still use NetBIOS name services, and it's purely for Microsoft machines and node type if you have that. So you can leave all that because it's already provided on the VPC level. And this, if you specifically have older Windows machines or purely Windows environment only, then you can use that. But Microsoft recommends to use DNS for name resolution nowadays only. Other than that, this is just tags, and if you want to put some command line, but basically with DHCP option set, you may give or provide clients this whatever you put here will be given to the machines. If you don't put anything, you don't really need to come here and create a DHCP. Options are because you remember that when we were creating EC2 instances, we didn't have to come here. We still got automatic IP addresses there, right? So we were getting all the IP addresses as soon as we created EC2 instances. So default DCP is already DHCP is already working. We really don't need to come here if we don't want to give them some customized information to the client. Don't have any such customized information. So most probably in companies you won't see this happening unless they want to share some customized information related to NTP, DNS, domain name, BIOS if it's much older network. I'm going to cancel out from here. So here as well. If we go for so elastic IPs, we already have done a lab on elastic IPs. It can be can create that IP and then associate it with the other machines, associate elastic IP, right? So we did that actual lab. You can just refer to that lab, how to use elastic IPs. But obviously these are public IPs, and then you have to pay for that too. And then there is managed prefix lists. So, some of the things here you might not use much because already they are provided by, the VPC, and by default they're provided. But what is the purpose of managed prefix list? If we go here, a prefix list is a set of IPv4, IPv6 address ranges. So it's a collection of IP address ranges. Suppose I go to the diagram and suppose you say that, hey, I don't want to use any other IP range other than what I define here. And I don't want anyone to use my network, suppose 172.16.0.0/24 and so whatever ranges you give, maybe 20 ranges you can give, 30 ranges you can give, and keep going like this with different subnets as well. That other than that, I don't want anyone to use anything else. So then it will, and that can go really. You can keep on defining then 2.24, which means 256 machines can come in, and then 3.24 and so on. So you say that other than these IPv4 ranges, IP ranges, no other ranges should be given to these virtual machines or this whole VPC. Then you go for a specific prefix. Here, suppose there is also a range 10.0.0, sorry, not this, 192.168.0.0/24. So you did not include that in your prefix list. So this will not be used. Whatever you used, put in the prefix list, only that range, those ranges, from those ranges, the IP addresses will be distributed to all machines. That's what. And if you go for create prefix list, it just gives you names. It just asks you names. Our prefix list, so I could delete it later. And maximum entries. How many IP ranges you want to give here that you want to be used in the environment, and not more than that. Suppose I say, okay, only 4 IP ranges. I want to be used in the network, and not more than that. And what are the IP ranges? Then you have to mention those. Suppose it's 10.0.0/16. Whatever description you want to give for VPCs, suppose please use that, and for 10 dot or 172.16.0.0/24 you can use maybe for any other range, and maybe for some departments, maybe for just other regions. You can just put any kind of description there, and then you can just start defining whatever you want to define here. And mine. So now, if I want to add another, it doesn't let me do that now. I cannot click here because I defined I only need 4 ranges here. So it won't let you create more. Right? Go here 5. Does it change real time? Yep, it changes real time. So if I go 4, then now it's not going to let me add. So you can put some ranges, reasons here, but overall, managed prefix lists is when you define it, then it won't let you use any ranges other than that, right? So then you can just, and it is here in the VPC, so it will be considered as, okay, these ranges I will use other than that, and I will not be using anything else in your subscription. Then there are endpoints here. Endpoints are, as the word says here, endpoint. Endpoint is some kind of service that you want to ultimately connect to. So some kind of service, what kind of service? S3. S3 bucket is a service, right? You want to connect to some bucket, uh, S3 service bucket through S3, or it could be EC2, or it could be, there are like 100 plus services here, right? So any of those services you want to connect, or you want to connect to on-premises environment. Suppose there's a Toronto branch here, right? You want to connect there. So that's where that would be considered as endpoints, right? And points. So endpoints, how do you connect a VPC to an endpoint, and why would you want to connect? Obviously, then there will be a connectivity established between that VPC. VPC is a separate service. S3 is a separate service, right? EC2 is a separate service. So you say that, hey, I want to have connectivity from S3 service, from a certain bucket even, but from S3 service to VPC. So whatever data is there can be saved in S3 bucket. So you want to have some dedicated connection to that service. Then you can create endpoints there. Now, how do we do that? Also, if we go to the slide here, yeah, DHCP option sets, we did that, and prefix list, yeah, endpoints. So connect VPC to any AWS service like S3 bucket, etc. And we do that. So I've just mentioned or some step-by-steps as well, because first time at least I've needed to create that myself as well. And I hadn't created that before. So let's go ahead and try to create an endpoint that connects a VPC service to S3 service, right? And then, S3 in which region you want to connect. VPC in East US wants to make a connection with the S3, which is also in East US. So how can we do that? So if we go back here to endpoints, and so endpoints is here, please. NK. So there was no errors, but okay. So I'm going to go ahead and create an endpoint, and that endpoint asks what is the name If I go for your first name and point, although I may have played that before, so endpoint one or your first name and then endpoint VPC to S3. S3 is the endpoint of VPC. Uh, and there are many options here as well. You want to connect the services provided by Amazon, or you want to go for private link ready partner services. So partner services that are services with an AWS service ready designation. AWS service ready designation. So this means that third party services that are connected to AWS. Then there is AWS Marketplace services. So this means that marketplace we already went through. There are so many vendors that are connected, right, to AWS services that are providing AWS services like firewall services to AWS, like Fortinet firewall. There are many famous brands there, Barracuda firewall and load balancer. So you want to have those guys as endpoints. So any third party would be, suppose Barracuda appliance that you have deployed here that has a firewall inside as well, or Fortinet firewall. Now that's a third party. You have to purchase a license for that. But is that your endpoint? You directly want to have a connection with that service, which can be hosted on AWS. One VPC can connect to that as well. Third party services. So if I stick to, and then there's other endpoint services, find services shared with you by service name. So if there are any services, for now I'll just select AWS services. Then it says, okay, now there are so many 100+ services in AWS. Which other service should be your endpoint? Now, 1, 2, 3, 4. So it goes on and on and on, and it shows you want to connect to backups service, you want to connect to batch service, you want to connect to Athena service. As we know, there are 100+ services, so it keeps on going with all the service names and you know. So what I'm going to do is I'm going to do a search here and S3. And in S3, so there is .com, Amazon, or US East 1 S3. US East 1 is North Virginia, right? And there is Amazon AWS.S3 global.access point. There is this. Okay, I want to connect an outpost. Outpost is like you want to download the whole AWS software on your own hardware, right? So you have to purchase a pretty expensive AWS partner hardware, and then you can download the full AWS software application on top of your own hardware, and then it will exactly look like this AWS, but it will be running on your own hardware. That is Outpost, right? Anyway, but it's pretty expensive. This is called Azure Stack in Microsoft. It is called Outpost here. So I'm just gonna click that. That I want my VPC, which I will explain here, to connect to this S3 service. Right? So con.AWS Amazon US East 1 S3. There's a gateway. You want to connect to S3 gateway or interface. So I say that interface because maybe I want to create a bucket there, and bucket needs to connect to the VPC. And when you create virtual machines inside VPC, they can dump their data to the bucket by utilizing some of the third service. Right now, it's one service connecting to another service. Right? So once I select that, okay, it's the interface, then it says, okay, which VPC you want to connect. So I just created Amazon VPC 2. And here it says that, did you create a subnet for Amazon VPC 2? I didn't. Okay, let me go there and create a subnet. If I go there and go to subnets, because these are all default subnets, and there is one test subnet that's connected to some other VPC. If I go there and I'll see 2, so dash subnet dash VPC2 subnet 1 dash VPC2, and just for organization purpose, I'll go for 1A, and the subnet IP according to the VPC IP. It's 24, and yeah, that's it. Hit subnet. Okay, so subnet has been created. I hope it detects that now. There's no refreshable. Refresh VPC 2. Oh, it does show VPC. Okay, I'll change it to VPC. It shows up the VPC subnet. Then again, go back to VPC 2. Yeah, I think this is the one. Yeah, Armor subnet 1, VPC 2. So you have to define a subnet exactly because the resources, the virtual machines, EC2 instances, they connect to uh, subnet, right? Now, that said, um, IPv4, I will select that. Yes, we're going to be using IPv4. And then it says, hey, what's the security group? So default security group, you can always change the security group policies that suppose it's allowing only port 389. We can just add port 80, port 443, HTTP, HTTPS, right? Port 1433, which is database port. Port 389, which is LDAP port or authentication, Active Directory authentication port. So there are many, many other ports as well, SSH port 22. So we can add any of the traffic. So from VPC, what kind of traffic will go that needs to be uh, told to the SG, right? So SG is in the, you have to how block traffic through SG, obviously. So there it is. And then policy. So obviously you're connecting to the bucket. There's the ACL, and through overall in VPC also, you can go for allow access by any user or service within the VPC using credentials from any Amazon Web Services accounts to any resources in this Amazon Web Services service. All policies, IAM user policies, VPC endpoints policies, and Amazon Web Services service specific policies, the bucket ACL policies must grant the necessary permissions for access to succeed. So, thing is, you want to do custom and give specific policies through policy creation tool that we have gone through before as well. Or just for now, we have full access to S3 service for VPC, right? And then we go down here and that's it. So overall, when you're creating an endpoint, you define the name there, then what kind of service category you want to go for, then which exact service out of the 100 services you want to connect the VPC to, and which VPC you want to connect to S3. In our case, S3 we selected, and what subnet you want to connect, and then is IPv4, and then what security group are you connecting. You have to define all that. Pretty much, if you go to the diagram, you're defining each component here, what VPC, what subnet, and what SG, what IP traffic will be going to which service. So all you define here in endpoint. So we go there, create endpoint. Now, there is the endpoint created here. And if we go on the other tab and then go to S3, then I quickly create a bucket here, and it's armor dash bucket 15 8 Also, North Virginia, US East 1, choose bucket. Now, ACL is disabled, recommended, ACL is enabled. I'm going to go for default ones. Block all public access, disable versioning, default encryption, everything default, nothing changed. I go create bucket. Oh, okay, bucket name must not contain uppercase. Ouch. So I remember that I have the public access blocked, right? If I go create bucket and go inside the bucket, and go to, we've gone through all this, right? Access points. And so it just says that access points, S3 access points simplify managing data access at scale for shared data sets in S3. If I go for a create access point here and put the name as honor dash access point in the bucket, and it says that which VPC to connect to. No internet access requests are made over a specified VPC only. The S3 console doesn't support accessing bucket resources using a VPC access point to access bucket resources from a VPC access point. It is CLI, it is SDK, or AWS S3 REST API. So if you want to transfer data from one place to another from VPC based EC2 instances to S3 bucket, then from console you cannot do it. Then you have to go for CLI and you must know some commands there. So VPC needs to be connected to. So I need to go to the VPC here, and I need to know the ID of the VPC. So where's the VPC here? It is this. It's not this VPC, it's this one. And this is the VPC ID. And I'll go back there. I copied it. I'll paste it here. Hey, bucket, S3 bucket, you should be connected to this VPC, and the endpoint has made that connection to the S3 service until the S3 service has connected that. So S3 service is there. Inside the S3 service, we have created a bucket. Right. So, but up till here, S3 service, just like telecom connects their connection to up till the building here, and then from there you need to make, well, there are other wires that go to the apartments and then give the internet connection. So anyway, protocol access point aliases, that's it. So this is the access point, and the access point we have given that this bucket will connect to the VPC here, and that's it. We want to run some policies there, some restrictions there. You can do that. If I click create access policy, it says access point name must contain uppercase, must not contain uppercase. Okay, so actually bucket is, it does not like uppercases. And go down here and create access point. Well, it doesn't give any errors. This means that it accepts that connection. So this is how from the bucket to VPC we can make a connection. Then any developers who wants to dump some data from the EC2 instances, suppose that are inside the subnets, inside the VPC, and they can use the endpoints to make a direct connection to the S3 service or any other service among 100 plus services. So now you must have some kind of application here that is dumping data to any of the S3 buckets. So that's endpoints, and endpoints. There is some more information that I wanted to give. A VPC endpoint enables connection between VPC and supported services. So we connected one supported service, which is S3, right? There are 100 plus services along. Without requiring that you use an internet gateway, NAT device, VPN connection, or AWS direct connection, direct connect connection. Therefore, your VPC is not exposed to the. That's the main point here. This connectivity that we made is over the backbone AWS network without connecting to internet. So endpoint connection is made on AWS backbone network without touching internet. That's the beauty of endpoint connection. That this is all private IP based connection within the AWS network. You're connecting from one service to another. If you don't use endpoint, then yes, your internet, and then you're connecting to S3 there. Suppose there's one virtual machine, one VPC, and another VPC. So yes, over the internet you can connect as well. Or if you have site-to-site connection, we already know that. Then we can have private connection, private IP-based connection, or through this private link. Actually, private link has not been mentioned here yet. This is endpoint. So one endpoint to other endpoint to AWS backbone. That's the main point here. AWS backbone network. You're connecting without touching internet at all. So if you're not going over the internet to reach the service, then obviously internet, there are so many hackers sitting there waiting for your traffic to leave your AWS subscription and go over the internet and then go to the other service. So the hackers might intercept that traffic and then can steal data as well. So you can avoid all that, right? So for that, the endpoint connection is there. If we go, so main point, you want to have endpoint, you can avoid public internet. You only use AWS backbone network. Then there's endpoint services as well. Seriously, what is endpoint service and what is endpoint? So endpoint service, first of all, this is a lab pending because so this is endpoint, right? So I showed the steps here as well for endpoint, blah blah blah, done, right? And but for endpoint services via private link, now that is also going to provide connectivity on AWS backbone. Right? AWS backbone is going to provide that. This means you avoid internet here as well. Endpoint service. So you can create your own application in your VPC and configure it as an AWS private linked powered service, referred to as an endpoint service. Okay, so other AWS principals can create a connection from their VPC. So basically, what it says in English is, let me just create a diagram for that. Right. So here, what happens is that suppose you created an application, and suppose this application is on a set of virtual machines here. I mean, one, two, or three virtual machines here, and you're expecting thousands of users to be connecting to this application, or you're expecting employees that are across the globe. You've hired many developers across the globe, and they want to connect, and they are your employees actually. So better to connect them on private network. Now there are multiple machines, so this means that there will be a load balancer to load the traffic. Each machine has the same application. So you deploy a load balancer here. So you deploy a load balancer, and that load balancer obviously balances the load. But when you're connecting from other VPC or from then you connect over the internet and then hit the load balancer, and then you are distributed. The traffic is distributed on the three virtual machines in a round robin fashion. Round robin means first user connects to the first machine, second to second, third to third, fourth to first, fifth to second, and sixth to third, and so on, right? So it's round robin. It's called round robin, equal distribution. So you hit that load balancer, and yeah, this is simple, right? People are connecting from outside, but what about it says here in your VPC and configure it? So you can create your own application, your VPC, configure it as an AWS private link powered service. Other AWS principals can create a connection from their VPC. So there is another VPC they are connecting from their VPC to your endpoint service using an interface VPC endpoint or a gateway load balancer endpoint, depending on the type service. So basically, what they're saying in English that there's another VPC or multiple VPCs, and those users want to connect with your application, and they want to connect on a private network. So what you can do is that people connecting from other VPCs will hit the load balancer, and there will be virtual private link that you will be creating. Virtual private link. The only purpose of virtual private link is to connect via AWS backbone, not using internet uh, for at all, not using internet at all. The purpose of that would as well be this, but this is on a bigger scale. Now, we talked about endpoints, and now there is that endpoint services. So just one endpoint is one service to one service, while endpoint service actually is it works behind either the firewall, either the gateway. This either it works with the gateway load balancer endpoint or endpoint service connection from the service. Yeah, an interface VPC endpoint or gateway load balancer endpoint, depending on the type of service. You are the service provider, so you're providing that application. You're offering that application to our users to use it, right? The AWS principles that create AWS principle is what? Users. AWS principles user AWS service that has username password. So anyone who wants to connect, you should put a load balancer there, and then they will be able to the connection. So that create connections. Your service are service connect consumers. So these are called service consumers that connect to your service with AWS private link powered. Now, if you go to VPC endpoint service here further, so different services require either a network load balancer or a gateway load balancer. The load balancer receives requests from service consumers who are connecting from outside, right? And routes them to your service. In this case, you'll create an endpoint service using a network load balancer for more information. So it actually tells you how to connect. If I go to the private link itself, this private link is a highly available, scalable technology that enables you to privately connect your VPC services as if they were in your VPC. This means you're privately connecting to services in other VPC as if they were in your VPC. So you do not need to use internet gateway, NAT device, public IP address, AWS Direct Connect connection, or AWS site-to-site VPN connection, allow communication with service from your private subnets. Therefore, you control the specific API endpoints, sites, and services that are reachable from your VPC. The thing is that you are again avoiding, whenever you say a private link, it's just using AWS backbone network, it's avoiding internet. Hence, the threats on the internet are being avoided as well because AWS, obviously, its own AWS private network is private, so it is secure. Right? So why would you want to go over the internet when you can use AWS private network? But obviously, whichever regions is available, that's where you can use private link. But if uh, in some regions that private link service is not used, then you will use internet service. So not every region has that. So it just says that private link is. I'll just put that here because private link is a separate definition here. There is a private link. So private link. And it's the good read is this link that should be there. So here, private link is a highly available, scalable. So main thing is you avoid internet, you get that point again and again. Um, and from one VPC, then private link to Amazon Web Services, any of the S3 bucket or any other service or provider VPC or some other VPCs as well or third party VPC. But you're just connecting privately to that. So, and it just gives you a lot of information and pricing as well. If we go back here, obviously endpoint services, we now hopefully understand that you can connect to other VPCs uh, through AWS backbone without touching internet. But this lab, this means that we have to create a VPC with T2 instance or load balancer, or at least connect the load balancer to the private link service. If I go to the create endpoint service here, so it says that, hey, what do you want to connect to? Network or gateway? Suppose it's network, then it asks you available load balancers. It will connect to whatever load balancer you have deployed. You must have a load balancer for it to connect, or you must have a gateway to connect. Right? So anyone, the load balancer has to be there, and then what traffic you're using, IPv4 or 6, that's it. So pretty straightforward. If you have a load balancer, we have created a load balancer already. If we had created that, you just show up here and simply you will link it. Load balancer connects to what? Load balancer connects to virtual machines, backend virtual machines, right? EC2 instances that we added in the load balancer lab. So you do that lab and then simply connect virtual private link to the load balancer. But that's not all. If you want to do the lab, if we want to do the lab, okay, connecting this is no big deal, right? But how do we make a connection through the other VPC to this VPC through private link? I mean, what's the proof that uh, there's that? So yeah, there's a question there which is asking, are there all theory or lab as well? So I have to cover all these, which I have to cover the VPCs here, VPC features here, but there is no big lab here. Yes, that would be side-to-side VPN. We've already done that. Customer gateways, we've already done that. I'll be going through some of these options step by step. Then I intend to go to the databases. Database will have a lab if we reach there because there's so much options there. Yes, it is boring to have theory only, but yeah, I have to create the step-by-step labs for some of the things. Like NAT gateways lab, I need to create, and endpoint services I have to create. But ACLs, security group, rule groups, domain lists, then firewalls. We will be exploring features, but it is all through. But obviously, we need to understand theory if we need to compete in the interview. But yes, I need to create some bigger labs still. Okay. So here, we're talking about NAT gateway. Actually, endpoint services. So this is lab pending because I need to. It's easy lab. If I just do it now, I can create a load balancer right away. and connect it to endpoint services. That's it. Right? I did that same private link lab for Microsoft Azure in the AZ 500 security course that finished today in the morning. And after the week, after this next week, we're starting Microsoft 365 4-in-1 course that would have Microsoft Exchange, Azure, SharePoint, Teams, and Intune. All four are, if you have those skills, you get a job much sooner than you think. Those are all job grabbing courses. So I put it 4-in-1 overall, and it's starting soon. Anyway, so their private link lab I did for Microsoft services as well. And the main thing about that lab is that if you do connect private link to load balancer here, then how do you connect another VPC to that? That's the main thing that needs to be understood. So I'll be creating quickly. It's not quick because creating a lab step by step and making it work ourselves is the most trickiest thing. It's the most challenging thing in a course, and that's what I love to do. That's how we understand properly anything. So this is still pending. Private link and NAT gateway. They are kind of simpler labs, but I don't have the step by step for that, and I want to give it. So yeah, I'll be doing that. Okay. Other than that, so NAT gateway. What is NAT gateway? We can just understand here, but then I'll be creating a lab, and you can see those that in the video. NAT gateway simply provides internet to private IP based uh, teams. So you can use NAT gateway, network address translation gateway, to enable instances in a private subnet to connect to services outside your VPC, but prevent such external services from initiating a connection with those instances. There are two types of NAT gateways, public and private. Public NAT gateway enables instances in private subnets to connect to the internet, but prevents from receiving unsolicited inbound connections from the internet. So let me explain that in English. And that is, suppose there are virtual machines here. There are virtual machines here, and those virtual machines are all having private IPs. This means that they will not have internet. If you give private IPs to these VMs, they will not have internet. Now, you want them just like our home machines that they have private IPs, and then they still have internet in our home because of the protocol called NAT in the DSL. Our DSL router has NAT protocol, and because of that, we get internet connectivity. So you have to deploy a NAT gateway, and that NAT gateway would just give internet connection. So NAT gateway, the benefit of that is NAT gateway that the machines get internet. The private IP based machines get internet, right? But they're still behind the NAT gateway, and they cannot be discovered. They cannot be directly connected from over the internet because they're private IP. They still get internet. Right? So you connect through public subnet, you connect to these machines, and you are able to connect through 3389 port. There's a NAT gateway that's providing them internet connection. So you will have internet connections here. Other than that, they're hidden behind NAT gateway, just like public machine. Suppose it's a public IP here. So you can directly connect to that machine. Here you cannot directly connect to these machines unless through VPC to VPC or subnet to subnet you have connectivity and you've enabled ports there 3389. But they still have internet connection. Publicly from internet you cannot connect to these machines. Still they have internet. You have to connect to them through other subnets only. That is NAT gateway. So what we can do is, I'll try to come up with a lab sooner that we will have one subnet, one VPC, and that subnet has just um, private IP based virtual machine, and then I'll put a NAT gateway. So at least this virtual machine should have internet. Actually, we have to check that with two subnets. One should have public IP, other should have private IP. We connect to the public IP based machine. From there, we jump to the private IP based virtual machine, but still, it should have internet connection as well. And that is only going to happen if you attach an NAT gateway to this subnet having private IP based virtual machine. So that's overall the purpose of that. That it provides simply, the IP information, the internet to the private IP based virtual machine, right? Well, obviously, these are some of the labs that I didn't do those labs even previously because they were much bigger labs. I did site to site VPN and others, VPC peering and others. So I normally don't do the NAT gateway and endpoint services. I just explain them, but now I think that there should be a lab for that too, so we could really understand how step by step it works. So endpoint services and NAT gateway labs. Soon you will see videos there. I will include it in the next class. About next class as well, there's Eid celebration could be on Saturday. If it's on Saturday, then yeah, it won't be available. But if it's on Friday, then yes, there will be a class. Peering connection, we have already done that. And network ACLs. So access control list. And now we know already security groups. Then why do we need access control list? So what does security group do? They block traffic, block traffic, which type of traffic you want to allow and from where, right? So you can allow log. But ACLs, what do they do? I think we did mention that before as well. So a network access control list, ACL is an optional layer of security for your VPC. It acts as a firewall for controlling traffic in and out of one or more subnets. So this is optional layer of security, and you can create an extra layer there. So that would be then extra layer here, and it's going to be this. So this would be the extra layer, and that's where you can just put ACLs there, and ACL would be an access control list. Control list. So what does it do? Today the weather is so good that only me and Razar are there. We can even have chutti soon because there is, fasting going on. Okay, so network ACLs is there, and here if we click the create new network ACL, so there is armor dash network dash ACL, and then we connect it to VC2. There are tags here, create new ACL here. Okay, so that's our network ACL, and it has inbound rules as well and outbound rules and subnet association. So you can uh, associate a subnet, edit subnet association, and there's only one subnet there that you can connect it to. For now, I have one subnet, uh, and okay, why did it come here? Did I not create association already? So this is subnet association, right? It's already actually connected to that subnet. Okay, and then That's just an extra layer of security, right? So edit inbound rules, and here then you can just decide what kind of traffic you want, and rule number for ACLs. It's pretty much you can see the same type of protocols there that security group also go for, and HTTPS. Suppose I go for HTTPS and protocol 443 and also not much difference between SG and that, but you can just put know extra layer of security as well. Rule number, so it's HTTPS number one and save changes. And then your rules are the rules of association. So um, here, so this is allow deny rule that you can enable on VPC level by connecting to VPC while security group connects to the C2 level. So that would be security group, SD and ACL. So SD is on the C2 level and access control is on the VPC level. Okay, so if I go there, well, that's wrong. Access control list is optional and can be uh, also used to create control traffic, right? So that would be it. And if we go down further, there are rule groups here. Rule groups are Route 53 Resolver DNS Firewall, managed firewall service for DNS queries that originate in your VPCs. So here, get started with creating rule groups to block or allow specific DNS queries. Create rule group, Route 53 Resolver DNS Firewall. So if we go for uh, create rule group, a rule group is a collection of rules with actions to block or allow specific DNS queries. So you want to allow or block specific DNS queries, then you create that honor dash dash group, and then I'll just put that here. Next, rules define how to filter DNS network traffic. They define domain names to look for and the action to take when a DNS query matches one of the names. So what is a DNS query? Um, so if we go back to the diagram here, and there's that DNS query here. That's suppose the DNS query is a name resolution, right? So DNS query is name resolution, no, query or question or query, where a service or a user or a machine is connecting to another service or machine by name. So you can allow block such queries as well with the rule group. So if we go for uh, rule group, it's supposed to be DNS rule group actually. So rule groups. So rules define and DNS network traffic. They define domain names to look for and the action to take when a DNS query matches one of the names. So then we can add a rule there, and then we can just so add a rule here. It says the names must have this description and my own domain list. So if I go for Ahmed one, suppose, and add my own domain list. So you can choose your own domain list or an AWS managed domain list. You want to allow those domains queries from your set of list of domains uh, becoming you want to allow them or to deny them that from that domain nobody should be connecting to my resources by name from this domain nobody should be connecting to my resources by name. So add AWS managed domain list. These are subscribed domain lists provided by Amazon. So if you want to have an allow or deny, so create a new domain list. Suppose you say then it says that okay, give us a domain list there. What domain you want to allow traffic DNS traffic to be coming from? So to bulk upload. Enter one domain per list. So domain list, armor domain list. And then, so suppose I say that CNN.com, So from there, I allow traffic. Choose an action to take when a DNS query fits the matches. So if traffic is coming from here, allow traffic, right? So add rule here, and then next here, set rule priority. It's the first one rule, and then add tag if you want to add, and then next, and that's it. So that's a rule group that which DNS from which domains the DNS traffic is allowed to come here, right? And domain lists here, yes, the domain list you can create here. I create a domain list there, but you can separately create a domain list here as well. Firewalls would be AWS Network Firewall, Managed Network Firewall service for your Amazon VPC. So that is obviously a firewall that lets you block or allow traffic on a large scale. SG security group it works like a firewall, but it's on the machine level. Then there's ACL that works on the VPC level, and then VPC and subnet level, and then there is firewall. Network firewall is a stateful managed network firewall and intrusion prevention detection service that allows customers to filter traffic at the perimeter of their VPC. So this means that um, you can just have a perimeter network, and at the edge of the network, whatever is entering your network, it has to go through the firewall. Choose a VPC that you want to protect and associate a firewall policy that defines the protections to apply. Select each availability zone where you want protection and select a subnet in each availability zone to host the firewall endpoint. Add rule groups to the firewall policy, and rule groups is where do you want to accept traffic from, right? Update the VPC route tables, update your route tables to send incoming outgoing traffic through the firewall endpoints. Network firewall will apply associated firewall policy to your VPC network. So obviously the concept is very clear that there is reference architecture is this. There's internet gateway. Through the internet gateway, there's a traffic going on. AWS network firewall inspect and filter all traffic entering the AWS network firewall. So it inspects and filters that. Firewall policy, stateless and stateful rule groups in a firewall policy define how to inspect and filter traffic. Also, there's public subnets and private subnets. So through the firewall and firewall policy, the traffic goes, right? Benefits and features, yeah, it's highly available. Stateful, there's stateless and stateful. So that is also AWS Network Firewall is a highly available managed firewall service. You can deploy a firewall in multiple subnets for high availability. AWS manages scaling required to meet your business demands. It didn't give the correct definition of stateful. I will show that later. Create firewall. So when we create a firewall here, as we know that it connects. So first of all, okay, under firewall, and then description. Oh, name is required. Then start and with a hyphen. Yeah, okay. I think I did that. Then there is description. Which VPC you want to protect through this firewall. So VPC2 pulls. And you can deploy the firewall in multiple availability zones into one subnet per zone. Right? So each subnet must have one available IP address. You can't change the subnet's IP address type after creation. So there is that one subnet there, and it's in this availability zone, and the IP address type is IPv4. So in one availability zone, one subnet needs to be connected to the firewall within the VPC as well. If I go here, your data is encrypted by default with a key that AWS owns and manages for you. To choose a different key. So we're not choosing a key here. Choose how you want to associate a firewall policy. Create and associate an empty firewall policy. Now there are firewall policies that you can associate or associate an existing. So suppose we go for new firewall policy, firewall policy, and rule order is default. So this means that first policy, second policy, third policy, that's how it's going to implement. You provide your rules in the order that you want them to be evaluated. So you can always play with the order of the what implements first, what second, what third. Delete protection, yes, protects the firewall against deletion. Use this setting to protect against accidentally deleting a firewall that in use. Disable it because I need to delete it. Subnet change protection protects the firewall against changes to the subnet associations. So I do want it to protect my subnets as well. So that's it. If I click create firewall, to create the firewall, a firewall connects the firewall policy with the VPC that you want to protect. Now it's provisioning or in deploying the firewall here. Associate firewall policy. So the firewall policy has no rule groups. So we will be adding rule groups here. So we attached the firewall, but we didn't add the rule group. So I'm just going to go for a stateless rule group, add from existing stateless rule group, create a stateful rule group. So we're going to be going for stateless and stateful. So I'll go for the stateless rule group here. And there, user. So first of all, honor dash rule dash group. Control A, Control C, Control E. Capacity maximum processing capacity allowed for the rule group. Estimated the stateless rule group's capacity requirement as the sum of the capacity requirements of the rules you expect to add. You can't change or exceed this setting once you have 100 rules I want to apply, although I'm going to create just one. And rule first, priority one, and there's choose protocol. So which protocol you want to create a rule here. And I see there's a huge list of protocols here, trunk, net belt. Man, that is huge. So I'll go for some typical one here. So it's RDP, or if we go for SSH or RDP, there's RDP here, 27. And for that, you can create a stateless rule. The source IP addresses and address ranges to inspect for. You can provide single address and CIDR block. So check all the IPv4 addresses coming from internet or anywhere connecting through with this IPv to our VPC. And then there is destination, so that's custom. It is also IPv4 based destination. TCP flags optional. If there is, you want to inspect TCP masks, the flags to consider in the inspection. So if there's acknowledgement coming from that, then check that synchronization or any other. Suppose it's urgent. So these kind of masks you can put there that if it's acknowledging packets, then check it. And then it goes flags optional, the flags specified in masks that must be set in the packet for a match. Other flags that are specified in masks must be unset in the packet for a match. Anyway, so the flags just mean to alert you. Action, choose how you want the firewall to handle packets that match the criteria. So pass, drop, over to a stateful rule group. So stateless just means that the users are connecting to your machine quickly and they won't be taking long. So don't investigate that user and don't go through that. Stateful firewall checks the connection of the user, the origin of the user, connectivity, how long the user is connected, who is the user, authentication protocol. Stateful checks pretty much everything in detail, in depth, in terms of security. And stateless, the user is not expected to stay long. So few things are checked, user authentication, what protocol user is using, is the user connecting from a legit source, and then the user is entered or let go into the network, allowed into the network. So action, choose how you want the firewall to handle packets that match the rule criteria. If they match the rule criteria, which is that is RDP traffic coming from anywhere, and so pass or let that traffic pass, right? And there are custom options or new custom options as well, but this is it. Otherwise, you add a custom action to publish CloudWatch metrics in addition to the standard rule action. CloudWatch simply monitors more and gives you more details of how long the connection was made through the firewall from the user to the firewall to the VPC. Right? So it's more detailed inspection. So there's that rule, add rule. You want to add another rule, you can do that, but that's it. But then it says that, hey, you haven't defined any rules for this rule group. Find resources. So this is just saying that for which resource you want to create that rule. So is it source port range? What is that? So I'm just going to click add rule, which is actually this. Did I not do that? Flag cannot be null. Okay. So masks, when I select acknowledgement packet, should be checked. So then it is also being checked. Now you can see that it's not letting me create a firewall stateless rule because there's no resource to attach to. Find resources, protocol, source, destination, source port range, destination port range, action, custom action, masks, flags. So this is group must contain at least one rule. So I did create a rule here. This is the rule, right? Go for add rule. It's just gonna. So yeah. So whatever I created up there need to be added here. So it added there. It's a pretty basic one. Then I click create and add to policy. That was a stateless rule created within Firewall. If I go to Firewall again, so that's still deployment is pending. It's a big one. So I can go for another rule group here. Oh, it's ready now. Firewall is ready. So I can go for stateful rule group. Right? And I'll go for our stateful group. And I will make here 20 rules. Actually, I will make here only one. Then it says your data is encrypted by default. Yeah, yeah, yeah. And with a key that AWS owns and manages for you. So I would want yes to let AWS manage it. And there's stateful rule groups. Remember that I mentioned that stateless is where users are not investigated long. Users are expected to not stay connected for long. Suppose there's a VPC that is providing services where users need to stay connected for long, then you go for stateful rules. And stateful is where it thoroughly checks the user's connection from every angle and investigate because users are supposed to be connected or expected to be connected for long here and stay connected. So more security is needed. So five tuple, use the five tuple format specifying the source IP, source port, destination IP, destination port, and protocol. Specify the action to take for matching traffic. Domain list, you want to allow block domains or Suricata compatible IPS rules, intrusion prevention system rules. Write advanced firewall rules using Suricata rule syntax. Suricata is an open source network IPS intrusion prevention system that includes a standard rule based language for traffic inspection. So whether you go for some open source intrusion prevention system rules or you go for at least check source IP, destination IP, source port, destination port, and the IP address itself. So yeah, I'll say to this that please check the IP, source port, destination IP, destination port, and protocol. And please, hey, Mr. Firewall, check that, right? Rule variables, optional, define IP sets and ports as variables. These variables can be used within this rule group. And you can just select that which network is that if you want. It's just optional. We don't need to select that. IP set references. An IP set reference is a variable used in your rules that refers to a resource associated with a list of IPs. So there's that IP set reference variable name, IP set resource ID, CIDRs. Yeah, so this is also you can define your own IP set, but you don't have to really do that if VPC IP is already defined. Now it says that create a rule. So the rule is it's IP based or TCP, okay, transmission control protocol. So it's gonna confirm the traffic. The source IP address could be what IP to check. So you can it is any IP or any port, and destination is any IP any port. Check all traffic direction as well, coming incoming or outgoing. So once you have gone through that, it is coming from. So suppose I had given my IP specific branch IP. The traffic is coming from some IP other than the branch IP, then it will drop that packet. Otherwise, if it's coming from branch IP, it will pass that, right? But I put any here. So obviously that will not be a good idea to pass that. But suppose I did put the branch IP here and destination VPC. So then it will pass that, right? I'm going to click add rule. So this is how to add rule and go through the. So is stateless and stateful IP addresses as well. So that's created. Firewall rules are created here, and so those are the stateless rules and stateful rules. And route traffic through the firewall. VPC route tables define network traffic flow. Update the route tables to send traffic through your firewall endpoints. For example, you can insert a firewall endpoint between your VPC subnets and an internet gateway or transit gateway. So it just says that associated VPC is this, right? And it says VPC tables define network traffic flow. So it says that you can insert a firewall endpoint between your VPC subnets and an internet gateway. So that you don't right now it's connected to VPC. So whatever traffic is incoming to VPC, it is already checking that. So but you can add specific endpoint. We talked about endpoint already, so you can add specific endpoint as well. Otherwise, this is how firewalls can be connected. If you go to firewall policies, so there is firewall policy here already, You can only delete that, but we have gone through the firewall already. Firewall rule groups, we have created firewall rule groups as well. Okay, a rule group and stateful rule group. The first one was actually stateless rule group. The other one is stateful rule group. The firewall resource groups. So if you have multiple firewalls deployed, then you can collect them in a resource group as well. We have gone through the VPN already, and then there's AWS verified access. And transit gateways and traffic mirroring, VPC lattice. So I'll be then sharing with you the rest of the labs in I will be sending videos for that, or I'll be uh, creating. I'll be in the next class. We will be going through that. So today's class we can keep it to these topics here: firewall topic, rule groups, domain list, network ACL, and then endpoints, managed preferred list, prefix list, DHCP options, carrier gateway, egress. So these are the topics that we talked about today. But I will be soon creating those videos for endpoint services and NAT gateway, and I will add it to hopefully this next class, guys. If if there's a Eid festival, so if it is on Saturday, then there won't be class. If it is on Friday, then yes, there will be a class. So these are not yet. So I'll let you know. Okay, guys. So this is it. If there are any questions, let me know. Otherwise, have a nice weekend.